Alrighty, we are live. We're a little early, but that's okay. Hey, Rich, how you doing? Link is there if you want to come up. I emailed it to a few other people. We'll see. Today, we were talking to our good friend Tom in Australia, and he was asking about generators versus alternators, and I figured who best to talk about that than our good friends Gary Bernacki and James Condon, Mr. Generator and bass guitarist 1985. So hopefully Gary will be here at 8. James has a bout with the C word. Don't know if he'll be available, but hopefully he can pop up with just even say hello. Schuster, how you doing, buddy? So we'll see how you doing. How you doing, Schuster? And hopefully they can come up. They're the pros. I am not a... Yeah, there's James. How you doing, buddy? Like I said, I am not an electrical pro at all, but I know between James and Gary, they can hopefully answer, especially the generator questions have to do with alternating current. I mean, we all pretty much know about car generators and magnetic fields and all that. That's fairly simple. But alternating current with the cycles and all that stuff, I figured Jim and Gary could probably say a little bit more than I could. All right, everybody's saying hello, Rusty Rooster. Hello, Rusty. Love your channel, pal. James is saying hello, everybody. Hope you're feeling better, James. I know my bout with that back in August was not fun, but I made the mistake of taking that medication, which did not help me. Well, it helped. I mean, it got rid of the COVID, but I had a cough for like 3 months. But anyway, everyone's saying hello. Yeah, our friend Tom in Australia, vintage engine repairs and actually spoon carving with Tom. Big channel, especially down there. He sells knife sharpening systems out of Australia, has a very good business with that, and does very well. Everyone's saying hello, Advil and Tylenol. I don't know if I took Advil and Tylenol. I did. I think I took that Lavox, whatever that stuff was that they gave me, and we went from there. But it did kick my butt for a few days. That's all. I tell you, Tom, I'm not afraid of old generators anymore. I really aren't. Since I met James and Gary and all them, I'm really not afraid. Adam, hello. How are you? Mr. Clem is in the house. Hello, Mr. Clem. Oh, let's see what we got here. Everybody's saying hello. Yeah, does it work? I tell you though, Jim, every time I watch that video of that one that you put hours and hours in. Oh, here's Gary. Hello, Gary.
What's going on?
I was watching your SPK base, whatever that thing was. Didn't understand a damn word of it, but I did enjoy it.
I'm glad you enjoyed it.
So, yeah, I mean, it's amazing how when it comes to electronics, I probably know 1% out of 100%. I mean, I can get myself in trouble, but when you and Jim start talking, like I said, it gets to a point where it's like, yeah, no, like that's over. But I still enjoy it though, because you guys are actually very entertaining. But I do get something out of it though. I mean, I know about potentiometers and this and that and the other thing. And as you're talking, I understand the terms, but then you get into some of the guitar terminology and it just, I'm done,
That's probably the reason why my videos don't get a lot of views, because I probably start
getting
onto a tangent about things that probably don't matter. But for that video, and for those that are not watching, feel free to check it out. It's the guitar that I've had for like 12 years, but then I put a preamp in, your bass, treble.
I love that color. Is that the color it came with?
Yeah, it's like a hunter green, but you could see the maple. You could see like the striation lines in the wood, which is the wood grain.
What is it, like a candy color or something?
Well,
it's a clear color though, right? So
you see it's a clear color.
Yeah, but it's definitely, wait till you guys see this thing. It is unbelievable.
It's my 5-string. Okay. Yeah, but you could see the lights reflecting.
Yeah, in your video though, it really shows up bright.
It does, yeah.
your
Well,
video. Yeah.
I'm using a lower color temperature light, but if I was
Yeah.
to do,
Hey, look who's here. Jim made it. At least he made it
that looks different in this light
in
now.
audio.
Yeah,
I
It's
made
a
it a
little
little bit.
Yeah.
I am quarantined in my house.
What do you have, 5 days, Jim?
Yeah.
Yeah.
Well, 2 days in. Actually, I feel good. I'm going to go out and work on something a little bit later.
He's the most interesting man in the world. Even when he's sick with COVID and Walking Dead, he's still working on generators.
I was tempted to do a Christmas live stream with you two and maybe Bruce, because I know Bruce loves talking about electricity, and give away a kilowatt meter or something, but I didn't know what you guys' schedules were like with the holidays and all that.
We're doing a Christmas Eve.
Yeah, you said
here at my house here, and for the family, and then there's a Christmas Eve at the in-laws, and then Christmas Day is usually just
we can even do it after Christmas, after all the hubbub.
Probably after Christmas. It's just so crazy.
I gotta head up there though, Gary. I gotta check your place out.
Yeah, no, I've been trying to get my band to come over, not even just to play, but just to come by, have a couple beers, just hang out. But it's that time of year. My female lead singer, she's into theater, so it's just just be nice that we don't have a lot of people over, just because of COVID too. And it's tough as it is, but
I'm hoping Tom shows up from Australia. He's literally 13 hours ahead of us, so it's now 9:00 a.m. and he usually gets up around 9 a.m. He actually was in the chat at 7:30 our time saying I'll be about 20 minutes late. So hopefully he can chime in, because I'm doing this because of him. Myself, and Stella, Lawnmower Lady, we were on a WhatsApp chat today, the three of us, talking about generator versus alternator and theory and all that. And Stella and I, we could get ourselves in trouble talking about it, but Tom was more like, why does this do that? Why? It was almost like talking to a 14-year-old kid who wants to buy a car but doesn't know anything about a car. And we're trying to tell him different things, but we didn't want to lead him astray. So I figured if I got you guys up here and he had any questions, at least you're more versed in it than I'll ever be,
Well, yeah, that's the interesting thing is, though, I've never really looked into it until you sent me that message, because people do correct me and they're like, it's an alternator, stop calling it a generator. I'm like, well, they're sold as generators, so I never.
But that was his question to me. He goes, yeah, but why are they saying it's AC if it's a generator? And I'm like, okay.
Well, there is a good point for that. I mean, so generator is a very general term. Generator can make AC current, or it could also make DC current. I think what a lot of people get confused with, at least the older cars, I mean, super old cars, used to actually have a DC generator in place of the alternator. But the problem with that they realized was that you had to run that DC generator at a very high RPM to get maximum output, versus an alternator where you have 3-phase alternating current and it's rectified to DC, but you don't have to run at a very fast RPM to get the full output current.
But he didn't understand rectification or any of that. So we had talks down to what is a diode, the check valve, an AC, and rectify, half wave, full wave, dirty, clean. I mean, we were getting into it. And finally I said, you know what, guys, let me see if I can do a live with the two experts, and we'll see if we can get some of these, rumors dispelled, and all that.
Boy. James, I think we might have our hands full.
No, that's okay. The biggest thing was we started off with, small engines used generators up until like the 70s, like 74 to 76, before alternators came into vogue. Okay. You really don't see alternators, rotors and stators and regulators and things like that until the mid 70s with a small engine, because he actually has a 1977 Johnson outboard motor with a rotor stator, but it doesn't have a rectifier regulator. It's missing. So he was saying, well, what do I really need that for? What's it do? So we were talking about why he needs it and how a rotor stator produce AC 2-wire. You have to rectify it for DC to charge and all that. And we were just giving him all the basics of that stuff because he was sort of in the dark about it. And I just wanted to have a little conversation about, what it was and what it is. And I started with him, back with Delco Remy, the original generator, what's his name, in 1909 when they created the generator, for cars. things like that. So it just started with, I sent him a video that AC Delco or Delco Ramy put out practically in the 40s about how a generator and his friend Mr. Battery and Mr. Voltage Regulator worked. And it was a really cool animation that basically said, here's a horseshoe magnet, cut the top off, you got north and south, put a wire through the field, you got voltage, things like that. And it's total sense and sensibility, but I wanted to start from like ground zero with him. If that makes sense.
Yeah, I was going to say, kind of related to this, but years ago, I created a pedal bike generator. I tried it first with an alternator, and that was a nightmare because you have to power the field. And with the generator, you can use a permanent magnet, or I think you can have a powered field as well, but it creates DC output. There's no conversion. The voltage is completely based on how fast you spin it. Like you were saying, like if you were in a car and you're idling slow, maybe the voltage wouldn't be enough to actually charge the battery. And of course, on the flip side, if you accelerate fast, especially if it's a permanent magnet generator, it's going to produce too much voltage. And that's kind of one of the benefits, at least of alternators and some generators, is that you can vary the intensity of the field to get the voltage that you want. And alternators especially, that's really the only way they work. I don't think there's permanent magnet alternators. I could be wrong on that, though.
You could have a permanent magnet, or you could have a powered field. I actually just have this is actually an interesting question too. I'm in the same boat as James. It's not something you usually think about, an alternator versus a generator, right? Like a generator in general terms is you could do either AC or DC current. A generator, if I'm not mistaken, it has what's called a communicator on it, or it's not like your typical slip rings.
No, you get a commutator.
A commutator. Yeah, right. Yeah, exactly.
Correct. Yeah.
Yeah.
Just like the old AFX race cars. They had the commutators.
So in this case, like, for an alternator, so you have your armature, right? Or the rotor. The armature is actually.
But see, that's the difference. In a generator, you have an armature. In an AC alternator, you have a rotor.
Right. That's right.
And I guess they're not, I shouldn't say they're not a lot different, but on a generator, the output is coming through the brushes, through the rotor.
Yep.
Correct. Well, through the commutator, through the armature.
Brushes, yes.
Yeah, and it goes to the brushes, makes them into electromagnets, and that's what generates.
And it's more expensive. I mean, if you have like on the generators we have, it's 240 volts split in the middle. So you need at least 3 slip rings for that. If you want auxiliary windings, you need more slip rings. I think just the size and the weight and the cost of making it that way is something that, for that reason alone, people aren't going to make it, because they can build an alternator generator that's a lot more simple. There's a lot less current going through the slip rings, and it's smaller, cheaper to build.
One question that Tom had, and a brilliant question, the generators that you and Gary and myself work on with the rotor and the stator, Tom asked me, well, does that generate AC or DC? And I said, yes. But I said to him, from what I've gathered, and correct me if I'm wrong, guys, because you're the experts, not me, a rotor and stator with the poles and the 60 hertz and all that, that's generating AC current.
Correct.
Now now in the DPU winding, all that stuff, you have to get 12 volts to keep it excited and other things. So, but what turns that AC into the 12 volt that you need for other stuff? It's rectified, correct?
Yeah, that's a separate winding. Most of the portable generators today will use let's talk about a brush type, because there's 2 types. You have a brush type and then you have a brushless type.
Yep.
So a brush type will use an automatic voltage regulator or something like this
attached to the brush, right? The brush block.
Right. So these are attached. So here's your DC volts coming out. That's powering the the brush assembly going through the slip rings to the spinning rotor. But what's powering it here is, well, wait, since you got me up here, these two little spade connectors are what, wait, I don't know where I'm at here. There we go. These two are inputting AC from your DPE windings or your exciter windings. DPE stands for displaced phase excitation. And all that basically means in layman's terms, think of your main windings like this. Your exciter windings are 90 degrees offset. And what that allows it to do is that when the exciter winding is at its highest point, at its peak voltage, it has all that potential energy to dump into the automatic voltage regulator, into the main windings, basically.
Because I was saying to Tom today, I said, look, you watch the videos from Gary and from James, and you guys are like, okay, yeah, we're supposed to look at this. Yeah, this is from the DPU, and we're doing this and this, and we're like, what? Huh? What? You know, because you got, I mean, people that know a little bit. In fact, when I watch your videos now, I'll actually take out one of my cheat sheets. So when you say, yeah, we're at the DPU, okay, that's this. Okay, you know, so I can keep up with it, just so I know what it is. But one thing that gets me too, and it's hilarious, is James will be looking at it. He goes, yeah, these coils here, yeah, if I'm not mistaken, 0.3 for the, he knows what the hell it is because he's done 4,000 of them, you know.
Yeah.
But guys like you and me, we don't, you know. And it's just hilarious watching because, like anything, James, it's second nature when you do it a million times, you know. And it's just funny because people ask me, how does he know that? How does he know that? That's all he does in his spare time, you know. So.
Well, it's easy too because the new ones are all very similar. Once you start getting into older stuff or smaller stuff, like some of the older Honda stuff, you know, the readings are not at all what I would consider normal, you know, for newer generators. But there's nothing wrong with it, you know. So yeah, it's easier with newer stuff.
Isn't the crux though, James, when you're looking at those? The first thing you're saying to yourself is, I hope there's no shorts, right? You're making sure that everything is continuous and all that. But I know every time you tear one apart, you know, the first thing you look for, you know, damage, burnt anything, you know, just a physical evaluation of what it looks like. But when you find one that looks like it's been in a swamp for 5 years, it's hard to tell what anything is. You know, like that one you were working on, Jim. It was like, oh my God, what is this? You know?
Yeah, the beacon. Yeah, I'd say 50% of the time it's very obvious. You know, either you take the cover off, you can see it right away, or you take the stator off and then you can see it on the other side. But yeah, occasionally you can't see it. And
it's hidden.
Yeah, it's not to say that it's perfect, but you know, that beacon one in particular had me stumped because it tested well most of the time, but every once in a while I'd get a little connection to ground. You know, I would drop from 10 million to 5 million to 1 million at one point. I'm like, yeah, there's something not right here.
Oh, here we go.
And resistance drops when the temperature increases. So,
all right, look what time is
coefficient, or I'm sorry, inverse coefficient.
Time is asking. So the rectified half wave is dumped back into the winding.
He's referring back to this particular automatic voltage regulator. Yeah, so in this case, this particular board has a large diode, which only allows electricity to flow one way. So think of electricity, alternating current, it's going 60 times a second back and forth both ways. So a negative.
You're only allowing half of it through, though, is that?
That's basically what this is. In this case, this is half wave rectification for this particular board. There are other automatic voltage regulator boards, and the Coleman's are a good example. I fixed a couple for James where they have a full bank of 4 diodes, so 2 are firing at the negative wave and the other 2 are firing on the positive wave. So you're getting
four like a Wheatstone bridge, or
no, just a regular bridge rectifier. This is a half wave, half bridge. There would have to be another set of diodes here.
Can I use synonymously then the word fake DC for half rectified AC?
Yeah, you could. It's half wave rectification is what it's referred to.
But it by being half wave, it acts like DC.
Well, yeah, you're still getting one. Well,
I'm saying for the layman, you know.
Let me just. It's better to illustrate with a picture. I think I figured out how to share my screen.
Okay.
That was all messed up.
Let me know, and I'll do you big? Oh, what's Wayne wire? Let's see. So lower magnetos putting out both AC and DC. Yeah, but Wayne, in our small engines, we have stators and rotors, 2-wire normally. 1 wire normally has a diode on it to rectify it into half to give you the DC. Okay. Now here's the question though, for the stupid people out there. Not stupid, but the people that don't know. I don't want to say stupid because I'll sound like a jerk. But anyway, you have a wire coming out. 2 wires coming out of your stator, both with AC. Usually it averages around 24, 26 volts AC. You have a diode on one of those legs. Now that diode converts the AC to DC, or it converts it to half wave rectified AC that we call DC.
It's still DC. It's just half wave if it's only one diode.
But I'm saying the 2 legs coming off the alternator, those are 2 AC lines, correct? When it comes off, forget the diode. 2 lines coming out of this.
Well, one of them's running the headlight, isn't it? So it doesn't need to be rectified.
Just say, for example, I have 2 lines coming off. Oh, we lost Gary. We have 2 lines coming off the alternator, Jim. Both of those lines coming off that measure, say, 26 volts AC at 3,600 RPM. That's pure AC right then, just the 2 wires. Yep. Okay. If you take one of those wires and you put a diode on it to charge your battery or whatever, right? Are we making DC or are we pseudo DC by using half wave AC?
Yeah, you're chopping up the AC, so you're only allowing half the AC signal through.
So by allowing half the AC signal through, it mimics DC.
Yeah, it's pulsating. So if you're charging your battery or something, it doesn't matter.
Okay. No, I'm just saying because people are saying, are you making DC from AC by using a diode in line with an AC output? Or are you just using half wave rectified AC to do the same thing?
I think it's in my mind it's the same thing because you're taking the positive, you're taking half of the AC signal, so it's never going negative.
Okay.
But it is still fluctuating, on the top part of the AC.
Yeah. Okay. No, because people always ask me, are you creating DC or is it still half wave rectified AC?
Right. It's not, if you look at it with an oscilloscope, it's going to look like a sine wave just with the bottom half missing.
Chopped off, correct. Yeah.
Right.
Yeah.
Whereas if you look at a battery, the voltage coming out is a flat DC.
Flat constant. Yeah. Okay. Yeah. All right. So you're mimicking what DC does. It's technically still AC though.
Depends how you define. Yeah,
hence
depends how you define AC, but yeah,
because people are asking me, and I go, guys, I know it works because you can power. You charge your battery from the diode line. He goes, yeah, but I thought it's supposed to be DC. Well, I said it's half rectified AC, so it acts like DC. He goes, yeah, but is it AC or DC? I said, well, it's
batteries are very forgiving. You can pulse it as long as it's not going negative.
Yeah,
you pulse it. And it'll be fine. And if you get a better rectifier with capacitors and things to smooth it out, then it'll look a lot more like DC, but you're still going to have a ripple.
Yeah.
It's never going to be perfect.
Huh. All right. Yeah, because I know that was great. What happened to Gary? I don't know if he was trying to share his screen or what. Because I know he said he wanted to show us a picture. Hey, Robert, how you doing, buddy? Because that's a question I get a long time. Sometimes I just tell the customer, "Don't worry about it. It works. Don't worry about it." I don't want to theory with them, and debate it. But it's just like I know what half wave rectification is, okay, with the diode. But then you're like, well, you're magically converting AC to DC. No, AC is still AC. It's just you're only using half of it and dumping the other half, and so it acts and works the way DC does. But they don't want to. They want to hear more theory, and it's like, no, I'm not going there. So, let's see what else we got here. What's next for you on projects, Jim?
Oh, geez, I've got a lot in the works. Working on a snowblower.
That's a better term, Adam.
Yeah, exactly. I just got it working, which is good because I didn't actually connect the snowblower to my tractor yet. So I'm looking forward to a nice big storm to try it out.
Hey, Wally. Wally is a good friend of Gary's. So, okay, let's see what we got here. Oh, we're trying to. Oh, Gary lost connection. Link, hold on. I'll throw a link out again. Hold on. Boom. There you go. Oop. All right, should be there. There we go. I emailed you two guys too. I don't know if you saw your Gmail. Let's see. Yeah, it's funny today. I mean, it was. Oh, there we go. He's back. All
Sorry
right.
about that, guys.
No worries.
I
Yeah, I
think
was just saying we were having a conversation, and I said to Jim, I go, and let me get your take on it too, because I think Jim and I were like, okay, if you have the two wires coming out of a stator and a tractor, it's 26 volts AC at 3,600 RPM. You take one of the legs of AC, you put a diode in it, it rectifies it to half rectified AC, which mimics DC, so you can charge your battery or run lights.
Right.
Okay, but it's not true DC. It's half wave rectified AC.
I think to put my screen in and I'll show you.
Hold on. There you go.
All right. So can you see the screen now?
Hold on. Let me get the other one. Hold on. There we go. Oh,
boom. There we go. Can you see that?
Let me do full. There we go.
All right.
Gotcha.
So here we are here, and if you see my,
Oh yeah, perfect. There you go.
Yeah. So there you go. So here's your alternating current. So here's your positive part of the wave, your negative part of the wave, and what we have here is a simple diode, just like how that voltage regulator works. Yep. Your check valve. So this only allows current to flow one way. And what is happening is that you're getting these positive cycles, but you're not getting the negative cycles. So you're basically wasting these negative cycles, because normally these negative cycles would be in between here. This is what's called half wave. So you're not getting the full output of the waveform of the AC waveform. You're only getting half of it.
Yeah, it's not alternating positive, negative, positive, negative, positive, negative.
Yeah. So basically, if you had another bank of diodes, you would get the full wave. So there'd be a hump here, another hump. So it'd be continuous humps. And so that's
what would that be called then, Gary?
That's full. Full.
Oh, it'd be full wave rectification. Okay.
Yeah. So full wave is.
What would be the difference though if you hooked it to a light bulb or something? Full wave versus half wave. No flickering or.
Yeah. So that.
Or the brightness when you revved it up or something.
So we're talking about snowblowers now, right? Yeah.
Anything with a simple diode and rectifier.
I would imagine the light would be brighter, right? Because the average voltage now would be twice. Right? So you were getting 26 volts out. With a single diode in there, you'd only be getting half that, right? Approximately. And if you had a full bridge, wouldn't you get...
But I thought the peak was the same, though, but it's the difference between full and
half. It is
half.
the same, but you can pull... Maybe I'm making this up, but I would assume you could pull more from that, because the average voltage is higher.
All right. What is Ortoria? If I'm saying that wrong, I apologize. Experienced electronics designer here. Once AC is rectified, it becomes DC, either pulsed or smooth. Okay, so that was my question. Do we call rectified AC DC, or do we call it rectified AC?
No, we call it. She's right. Pulse DC. So pulse DC means that it's rectified, meaning that there's no smoothing capacitor or capacitance in the circuit that allows you see those humps. But that's not that's not always desirable in a circuit. So we add capacitance. So every time that hump is charging up the capacitor, the capacitor takes part of the load.
Okay, I got you.
So the higher the capacitance, the less what they call ripple in the circuit. And that's a very basic type of rectification circuit to make DC. But in audio circuits, for example, that's just the rudimentary way to get basic DC. Then you have to run it through a bunch of other filters, even clean it up further, because the more, even a couple millivolts or a couple hundred millivolts of ripple up and down from those humps, even if it's smoothed out, is going to create noise, and that 60 hertz buzzing or even 120 hertz buzzing if your rectifiers are bad.
Yep. Wayne, what is it you're looking for, Wayne? I know you're saying Jake wants to run lights and heated grips. Yeah, but you got to look at the capacity of your rotor and stator, though, the amperage that it can put out, because I know when I've tried to do that, either the grips will work or the light will work. You don't have enough power for both.
I've done this. Check out my channel. I've done this on my air and snowblower already. So
what did you do to get more output, though?
I had to change out the stator.
Oh, that's okay. But yeah, more. Yeah.
Typically, and it depends on. So I have an Aaron's Platinum 30 from 2011, and it had a 60-watt stator, a half moon stator, so it was only half goes around, and that was able to run the 120-watt incandescent bulb and the 40-watt heated hand grips. That's typically what they're rated for. And if I wanted to, now what a lot of guys do is without changing the stator there, what they'll do is they will convert it over to LED because the halogen light isn't really that bright. It throws, but it's not that bright.
Yeah, it's sort of a cheating halogen, like
Right.
those bulbs you get for your cars. Yeah.
Right. So, and now there's a couple different flavors. You can actually download it off briggsandstratton.com for like the different kinds of stators of what's available. The one that I have was just pure alternating current. Nothing. If you had an onboard battery, there might be a single diode, or you had a dual charging system where one side charges it with DC, half wave rectification DC, and then the other half is still the alternating current, like if the diode wasn't there, and that's what's powering the light. With the heated hand grips, typically it's just alternating current. Now, if you wanted to put an LED light in there, now LEDs, at least for a 12-volt system, you need to have DC. You can't use alternating current on an LED
But you also need the resistors though in there too, right? So it doesn't flicker.
No, not a resistor. You need a full. In this case, I put in a full wave bridge rectifier. So that's basically 2 8.
Oh, okay.
It's four conductors. So
Yeah.
the two for the alternating current input, and then on the output the positive and negative. But what you do is you put a large capacitor in there.
Okay.
Because that's
is that the kit they sell you where you plug it in when you buy it for your car so it doesn't flicker and all that crap? Is that
that's a large resistor. That it's two different things. I actually used to have that on my Honda for the headlights. You needed a load resistor so that it would trick the onboard computer to not throw the idiot light that says, hey, it's got such a high resistance, it doesn't realize that there's a bulb in there. So you put these load resistors down in there to basically act as a dummy load, but it's just it's this large, 25 watt or 60 watt. Basically, it's a large resistor. It gets very hot.
Yeah. I want to get back to Oratoria for a second because I know there was some more comments and I don't want to ignore anybody. Saying it can't be both, talking about the comment here where you got pulse DC or smooth DC, and then she says it can't be both. So you can either have pulsed or smooth, right?
Right. It's just the difference with having a capacitor and circuit.
Worked in calibrated lasers. Cool.
Nice. Cool.
Yeah, let's see. So I know. Hey, you know what, Oratoria? I'd love to have you whenever we do these panels. Anyone that loves electricity like these guys, and I do too. I just don't know that much about it, but let's see. Oh yeah, Wayne, that's why we have these live streams. I love talking to these guys. Let's see what else. All right, Tommy's asking. What does he say? So the cap causes impedance to smooth the waveform?
No, it just adds capacitance to the circuit. So it's basically the 12 volts that's coming out of that bridge rectifier.
It's taking the spikes though, right? Taking all the dirt, or what's it doing?
Yeah, it charges up.
It charges
up really quick on the peak of that wave. So when the wave goes down to zero, the capacitor, kind of keeps things going until it can charge up again.
Yeah. So instead of it going up and down like this very drastically, it's doing this instead because it's running off of the capacitor.
I got to get a cheap scope, just so I can start looking at some of this.
There's this nice Silgent scope I want. It's a four probe. It's like they had it on sale. I just couldn't afford it. It was like $380, but it does everything that I would want it to do. More than enough resolution for the type of stuff I want.
You were talking about Briggs, Gary. I have that chart somewhere in my shop, which shows like the 25 different ones.
Yeah, I have it on my phone, but it's really cool to have. I mean, depending on the type that you have. So you got a blown engine installing on a good 1350 series, along with it like I said, it depends on what type of stator that you have. If it's just the alternating current, alternating voltage that doesn't have any diodes or anything like that in there, then you would need a full wave bridge rectifier.
But Gary, you didn't have to change your flywheel and the magnets?
I did not have to change the flywheel. So there's only two flavors of magnets. You either have the large magnets, and there's only like 4 or 6 of them, or you have the ones with the smaller magnets, which are the more common, more modern ones. They have the little smaller magnets, but there's more of them. so you get more output availability.
There he is. There's Tom in Australia. He finally made it. He's the reason I'm doing the stream.
Ah.
So, Tom, if you have any, Tom, there's the link out there. Why don't you come up, buddy? Just so in case you had any questions. I'm doing this for you, pal. So the link's down there. Come on up, and you could ask
Got a good amount of people on here, I think.
Oh yeah, I mean we'll get there. But like I said, that's why I like doing the lives and tech. I mean, people break my stones and say, "Oh, I already got to do all this technical crap." I like the technical crap. I'm sorry.
Yep.
So, what's on Turner? You're saying yes, capacitance cause what's called smooth. However, there always seems some ripple. Oh, who's in the basement? Is that Tom? There's Tom.
Hey.
Oh, what's going on?
Yeah, not much, man. I just got back from a bike ride, so
There you
awesome
go.
to be able to catch you. Let me just put you.
Now it's what? It's 9:30 a.m. in Perth, Australia, correct?
Yeah, that's it. That's it, mate. Yeah, thanks for putting this together. And
No, I figured get
Gary
the
and James
experts.
for coming up
It's
and-
most of our friends though, like in UK, they're in bed because it's 1-2 in the morning. But
Yeah.
you're just getting up, so it's
Yeah.
good for you. You know?
Even
Yeah.
if we're not that far behind you. This is usually around 9:30. Where my wife and I were like sacked out on the couch with the pups by that point.
Oh, really?
I don't
what
know,
time do you
I'm
normally
old.
Oh, fair
Oh, here we
enough.
go. What size capacitor across rectifier?
Good question. I think. Let me see if it's in my DigiKey cart. I remember doing this as a project.
Oh, you bought one?
Yeah, hold on. If it's not
Okay.
DigiKey, it is on my Mauser. It's fairly large. It is fairly large. I think
Now, I always make the mistake and mispronounce the farad rating of a capacitor is microfarad.
well, it could be microfarad, farad. It could be
megafarad.
Meref. Yeah, well,
Farad.
they
Okay.
don't usually they're usually rated microfarads, and then you go smaller like nanofarads or picofarads. We're
Yep.
talking really tiny.
Because I think I said megafarad one time, and the guys crucified me. It's micro, and okay, because I saw the mu there, and mu is usually micro, right?
Yeah, microfarad is the most common. Yeah.
That's really interesting because whenever I was doing stuff on points and condensers, and I'd look at the IPL for the service manual for what the reading of the capacitor is, they'd always, as you said, they'd always say microfarads, but mine only reads in nanofarads, and that seems strange that it
That's
wouldn't.
3 more decimal places. Yeah.
Well, yeah, but correct me if I'm wrong, because I don't work on a lot of point stuff, but I thought that was just to kind of dampen the spark coming back from the primary across the points gap. So it doesn't need
Yes,
to
you
be a
don't burn
lot.
out the point.
Yes,
Yeah, exactly.
All right.
but the strange thing is you still get that spark across the points, even with a working. I don't understand why you'd get that.
Yeah, I was wondering the same thing. If you just had a bad, like bad cap in there and you pulled it out, it would probably still run for a while
Yeah, but
before you
I
burn
had
out the
that
point.
problem. It would not rev up though
doesn't-
because it
yeah.
wouldn't have enough juice going through it.
Yeah, I had the same thing, and one. It wasn't a bad cap actually; it was a CDI that was failing, and that caused some really weird stuff.
All right, Wayne, take care.
Almost got it here.
Yeah, check out Gary and James's video. A lot of good stuff.
All right, so the minimum. All right, I'm finding I'm going to send my link to. I did this on the snowblower forums years ago. I actually did. What did I put in there?
Hey, baby.
So the minimum 2200 microfarads with a full wave bridge rectifier. I'll send you guys the link here.
And that's to act as smoothing.
That should be enough for a 20-watt LED. 20 watt equivalent LED. It's not taking 20 watts, but let's see here. You could go bigger. You could go 4400 microfarads, but that's if you're trying to pull more current, and you have to replace the stator for something bigger. I went with a 10 amp stator, which I think is one of the bigger ones for the. I think I do have a 1350 or a 1450 series Briggs and Stratton on there. It's the 342 cubic. What is it?
Oh, okay. Wally's saying
Cubic inch, I think.
micro. Okay.
Yeah.
Just to go back to our friend Arturia, and welcome again, Arturia. I really do welcome you to the channel. You're in the UK. I have a ton of friends in the UK, so welcome. Hopefully, you'll visit our lives more often. I do one a week. I'm on Mix when he does a live. A lot of friends in the UK, so we love the UK.
I don't know if I can post. I can't. Looks like I can't post the to the comments here. I could do it in the private chat.
Why not?
Hmm.
Are you on? Can you go into YouTube and then do a pop out?
I could do that. Yeah.
Sometimes that's easier.
I just didn't want it to double talk here.
Yeah. Well, no. Then just go to the pop out, minimize it, and then shut off X out of the YouTube. It'll still be in there. You can pop it back up.
Okay, here we go. Pop out.
Yeah.
Bingo.
Then you get the double modulation. Then just minimize the pop out and X out of YouTube, and then bring back the pop up. Because that's what I usually do. The only reason I'm in the StreamYard chat is I can post people's comments. I can't.
That's why, yes. All right, so then let me just do that again. Sorry for the double talk.
All right.
You're the live stream master.
Pause it, then pop it out. There we
go. Back EMF. Reluctance to break a connection equals spark. Okay. Let's see.
There it is, guys. That's the conversion I did to my, and even has the model number.
Why can't I see it?
Oh wait, that is not the. That is an old one.
What's
New member. Oh wait, that is an old one. Dang it.
Oh, cool. You got a channel, Arturia? If you do, please post it. I'd love to take a look at it.
Oh, here we go. Ignore that link, guys. Sorry about that.
Hey, Francis. How are you? Everyone's saying hello.
Let me go get one more.
Jeff is around. Hello, Jeff.
Oh, here you go. This is the one you want. That is the one you want.
Is it posting? I don't see it.
Nope, I'm coming. I screwed this up here. Ding.
Oh, cool.
This is the link you guys want. That's the one actually that I did for my own machine. I have pictures, videos.
Is it up? Because I don't see it in the chat.
I just posted it.
Hold on. Oh, usually it takes a few seconds in the StreamYard.
Oh, in the StreamYard it takes a little extra? Right,
yeah, usually. You know what I'm going to do? I'm going to mute myself for a second, and I'm going to do the pop-out as well so I can see everything. So
yeah, I just did the same thing, too.
I'll be right back.
Yeah, I wound up... All right, so I put in a 4,700 microfarad 50-volt cap. And I did the Molex. I did all that stuff. It gets kind of complex, but that's basically. I went crazy. You'll see on the pictures. I did the 2 spotlights on the top of the bucket, and then while I did have this kludgy looking on the wood, it kind of looks like doom bugs. I have 2 floodlights up on the top of the cab that I had. But I realized that was not really practical, so I put them on the side instead, and I got the proper tube mounts. So that's what it is now. I don't have an updated picture. It's been a while since I've updated, but you will see the pictures of how I added the new upgraded stator and put in a voltage regulator in this case. But the Briggs stator is a 695466 is the part number.
You're muted, Kenny. Kenny. Oh.
Gary, let me make you a mod. I'm sorry. That's why you couldn't do it.
Ah, okay.
I have to get into YouTube to do that, though. Hold on.
Thanks, Stella. That's lawnmower lady, right?
Yeah.
Yeah.
I can't see these comments. Hey, Gary, are you on your mobile or are you on a computer?
I'm on a MacBook Pro.
Oh, okay.
Just got my
Gary, post something so I can make you a moderator in the chat.
How do I post?
Just post something in the YouTube
gotcha.
pop out. There we go. All right, hold on. Add moderator. All right, now you're a moderator. So now you should be able to post something, links and whatever.
Might take another second. I don't have the little. I
You're
can do it in the private chat, but
yeah. Hey, Stella, how are you, hon?
Oh, there we go. I think something happened. No.
Yeah, I thought I made you moderator, but now you are, so that's good.
I might actually hold on. Weird. No. Well, let me do it.
Wow. You're definitely a moderator.
I might actually have to come back in. I don't know, but
You wanna
either
try
way,
it?
I have the other pop-up. I can always
Yeah.
add in stuff. But yeah, for the second link that I sent everyone, you can actually see the modification that I did with my snowblower, since we're talking about that.
Interesting.
So I've got a quick question. If an alternator is not only more efficient but can produce more power and is smaller, why do we have, this may sound really stupid, so excuse me for this, why do we use a generator setup to generate electricity that when something like that is designed to be portable? So your original question, Kenny, is alternator versus generator, pros and cons or whatever it is. Why would you not use an alternator to produce?
But we do. Nowadays, it's all alternators.
Yep.
Generators sort of went out of favor in the 70s.
So the stuff that James and Garrett, like everything that
I think
Those are alternators.
it's more of a
They are
semantics
alternators.
thing.
Yeah.
We call like home generators. It's just because it generates power. It doesn't have anything to do with generator DC versus alternator AC. It's like Kleenex versus tissue. It's the same thing.
Yeah,
that's
it's
right.
just a marketing thing. You know,
Exactly.
I think
All marketing.
Exactly.
they're all marketed as generators, and
Yeah.
you know, I guess people who don't know any better. I mean, it
Adam,
sounds
Gary,
better.
can you email me that to the Gmail, those links, and then I'll post them?
Yeah, I'll do it in the private chat here.
Okay, good. I'll take it from the private chat. Sorry, James. Go ahead.
Sorry, James, what were you saying?
No, I pretty much said it. It's just all marketing. You know, it's in a generator to me that sounds more intuitive, that it's making something, or as an alternator, I don't know. You think of your car, but it's the same thing. It's the exact same principle on how they work.
Oh, my favorite, Snowblower Forum. I love that place.
Yeah, I'm on there all the time.
So one more question. So the generators, they don't all have brushes and slip rings. They would have a commutator if you wanted DC. Is that correct?
A commutator with brushes is a traditional generator.
DC generator. Yep.
Yeah.
Okay, and what's the alternative?
An AC is a rotor and stator with poles.
See, I thought that was the same with a.
There are
DC.
similar componentries, but AC generation is different than DC generation. By the way, it does it.
I think too, generators, because the current's actually coming out through the slip rings that you use, you could also set up the slip rings in such a way that there's actually a break in the ring. So when you get 180 degrees around, it reverses the polarity. So you're actually kind of just getting pulsed DC out from a generator. And it's all mechanical. You don't need diodes or anything like that. Whereas like generators that I work on, they're alternators, and if they only produce AC. And if you want DC out of it, you need a bridge rectifier or a diode of some sort to do that.
Yeah. You had asked that, Tom, is a generator like Jim works on all the time pure AC? And if it is, where do you get the DC from? And he just said it. So,
yep. In all the other generators that James and I work on, there is DC output. So and this is not really used much here in the United States anyway, at least I don't see it happen very often, is that there are small bridge rectifiers inside the end bell of the stator, and those will either go up to charge the onboard starting battery for when you're cranking it. That's what charges the battery.
Well, the hour meter too, right? The hour meter and all
sometimes
that
the hour meter can run on AC. It all depends. The second bridge rectifier that I typically see on the Briggs & Stratton, Generac and all that will be going to a special DC outlet plug. It's got two on the angle blades that will come on. Then it has two alligator clips you can connect to a battery, and it's basically 10 amp output. I just don't see that many.
Isn't that normally though binding post though when you see the 12 volt generator?
Sometimes on some of the older ones, yes. But I see that DC that DC output, either 8 or 10 amps at 12 volts with just a simple bridge rectifier and an alternating current winding that will, again, it charges a small battery bank. again, I just don't see, it's not something that's practical in today's day and age. That's why you're seeing that feature less and less. The inverter generators these days, the small suitcase types will just have, the regular AC output.
Well, let me ask you, when you see like an inverter, 3,000 watt for the little ones, the 12 volt that's on there is what? Basically just to like trickle charge your car battery, or what is it really for?
Correct. Correct.
Yeah. Well,
It's
here's
just
a
not something
question.
practical.
An inverter generator, is it a generator or an alternator?
It is a three-phase
Oh,
alternator.
No.
It's right.
I was curious.
Wait, Tom, just remember, Tom, you could go back and watch this and take notes.
Yeah, I'll have to watch it a couple times because
Inverters are a completely different beast of a generator type, but the way that they're typically built is that you have a three-phase AC alternator with a rotating with a rotor in the middle, and it's got and typically for reliability purposes they have a permanent magnet rotor. So the only way that it's, so there's no commutator, there's no slip rings, there's no AVR or anything like that. The output is dependent on the engine speed because you have a fixed amount of magnetism that's spinning inside the stator there. So the three-phase AC is then rectified back down to DC, very high voltage DC, and then it goes through the inverter unit, which will then clean everything up. It just basically takes the raw power, and then it will use transistors to output a nice clean sine wave. So
now that inverter, is that the same as a regulator?
No, it is not. It is taking very high voltage, so it's
actually working in reverse though, Gary. Right? You're going back to AC.
So you're good. Yeah. So he's right. Yeah. So what's basically happened is the engine spins an alternator, three-phase alternator, AC, to get high voltage AC. Yeah. It'll then take that high voltage AC, which you really can't do much else to it other than rectify it. It'll dump it into very large input capacitors. So you got a higher voltage DC, and then the inverter unit will take that high voltage DC. And then using what's called pulse width modulation, it'll instruct the output transistors to pulse at very high frequencies to create a approximation of a true sine wave at 60 hertz. Now, the only problem with inverters that I find most of the time is it's not total harmonic distortion, meaning that the wave is not clean. It's very clean in terms of a true sinusoidal wave. It's that pulsing of those transistors that it's in the AM frequency of the AM radio frequency band that you get a lot of that RF hash. Noise, if you're a ham radio, you hear a lot of that hash. The only way to get rid of that is to use, and good inverters will have filtering components to get rid of that, so you wouldn't even hear it. On some of the cheaper generators, I will say that it's much more prevalent. Like there's guys that I've talked with that are really into ham radio, another hobby that I'd like to get into. I just don't have the money for it. If they're running inverter generators, they have a lot of problems with that unless they're grounding to a nice ground rod, or they're actually using the inverter generator to power a battery charger and they're running their radios off of a battery. And now you negate any of that interference that usually comes through. But inverters are a very different beast, and when they break, and they're almost impossible to repair because
but you need that for the clean power.
If you want clean power,
expensive electronics,
right?
But now we run into, how about the age-old question though? How about a filtering system versus inverters? I mean,
so there's no way to properly filter total harmonic distortion. Okay. So total harmonic distortion, and please feel free to chime in. This is what I know. I may not know exactly.
Hold on, I just want to tell the audience this is where he loses me. So,
so when we're talking about 60 hertz that's coming out of your wall outlet, total harmonic distortion refers to all the other intervals. So you have 60 hertz, then you have double that, 120 hertz, and then 240 hertz. You have power in those higher frequencies that most devices, if any device, can even take advantage of. So it's wasted power. It's being converted to heat most of the time, and that is kind of that's the basic risk when you're running more of the modern power supplies, like your wall wart for your phone or your computer power supply. They use what's called active power factor correction. I'm not going to get into that, but it's just basically those extra harmonics from most generators that you get, the 3,000, 4,000 watt typical alternator direct drive generators that you find on the market have very high harmonic distortion, anywhere from 15 to like 35-40%. That's very dirty, and that could wreak havoc on a lot of sensitive electronics. But an inverter, no more than 6%, I think, is the
And
limit.
that's why they cost a lot more.
That's why they cost a lot more. Now, I mentioned that hash or that interference. As long as it's below a certain level, it usually doesn't bother those a lot of those components or those the devices that we use every day. Now, if you're in an audio application, you might have a problem, but there's solutions for that. So that's kind of more the exception rather than the rule. But there really is no way to filter it, not unless you get an inverter generator or you're converting from that dirty power to a battery charger that can handle the dirty power, and then going to a DC to charge a battery, and then powering a nice clean sine wave inverter. You know, there's ways around it, but there's just very expensive ways around it that really is kind of a waste.
Cool. Hey, Adam had a question here. Dirtier power out of a brushless generator?
You do, yeah.
All right. And then another question here. Would you rather have I'd rather have an AVR than a capacitor or a non, because AVR you can adjust, right?
Some of them, not all of them.
Yeah.
AVRs do react to instantaneous loads better than brushless types, because the brushless types are relying on the large capacitor to regulate their voltage and output by the engine speed. AVRs have what's called a negative feedback loop, which, without getting too technical, basically it'll react faster if it senses the load is the voltage is dropping, because it's got a very large inrush of current to, say, start up an air compressor or an air conditioning unit. That'll sense that, and the feedback loop will output more power to the rotor field to compensate, and it will constantly stay in that use that feedback loop to keep that voltage constant. I would prefer it. The only con to that is that you have a wearable item such as a brush assembly.
Now, I'm not going to claim to even know what Arturia is saying here, Gary. So I don't know.
Yep. The bandpass filter choke. So she's talking about all those higher frequencies that we don't want. We use a low frequency, low pass filter basically to convert all that to heat in usually a ferrite bead or using a resistor.
Oh, I've seen those. The ones with the real thick wire wrapped around.
Exactly,
Oh,
and that's what you're basically.
What's that called? A ferrite choke? Is that what it's called?
Ferrite choke. Yeah. Okay. So it's basically it creates a high resistance to those higher frequencies, and it converts that energy to heat in that bead and dissipates it away. And then you can do resistor capacitors, resistor inductors, or inductors and chokes are one and the same thing. But yeah, Adam's right. Power factor correction can get very complicated.
Oh, we did a whole like 20 minutes on it a few months ago when we were talking, and you guys started getting into some crazy stuff. Yeah.
But back once upon a time, back in the early 90s, and I think they became more prevalent, you had passive power factor correction, which is simply a capacitor, because most of those power supplies, some of the first computers I remember, the compact Visario, one of the first computers that my family got, it had one of those power supplies, and you could run it on a square wave if you wanted to, because it didn't care what you fed it. It didn't matter how clean of the AC waveform is, because it was just going to rectify at the DC anyway.
Yeah. Now, didn't we talk about this when we had a discussion on UPS, the uninterruptible power supplies?
Yes, we did.
Okay, because I thought we talked about it.
And there's many different flavors of UPSs out there.
Yeah.
Some of them can get very, very complex.
We got Boo Luquette in the stream, but Boo, just a word of caution. We're only talking about generators and alternators here, just so you know.
Okay, well, y'all got off the subject a little bit. Not really, but with the power supplies, converters and inverters.
All right.
Converter is like 110 to 12 volts, as one like that. That's just a little cheap 7-amp power supply.
Yep.
Old pyramid style.
Yep.
They good. They lasted a while. This one's about 35 years old. Had one just like that in my radio shop.
Yep.
When I was in business at Tiger Truck Stop. Inverter, 12 volts to 110.
Yep.
That's just a general rule of thumb. Converters, inverters.
Yep, that's right. And that
Your
converter,
this power supply from 110 to 12 or 13.8 actually is heavy.
Yep.
Got a big piece of iron in it. Transformer. Plus voltage regulators. I think this one only has one in it. I
Yep.
hadn't read it for it, but there's nothing wrong with it. So never had a reason to take the cover off. Switch mode power supplies. Totally different animal than that. This right here only has 7 amps. Used to have a 40 amp in my radio shop for bucking linears and stuff like that. Amplifiers. Needed the amperage. 80 pounds. Big piece of steel. Transformer. Switch mode power supply. As in a computer. What are they? ATX, I think.
no, there's many different ones. Yeah.
I can get 70 amps out of a switch mode power supply. I can get 70 amps out of that computer power supply. Sometimes more with a higher wattage power supply. And light, real light. But the switch modes, like on my workbench, electronic workbench, I got LED lights. They don't cause a lot of noise, like fluorescent, spectrum over the airwaves. Switch mode power supplies are a little bit noisy. Not much. Not much. If I have a problem diagnosing a circuit, well, I just turn this one off. The switch mode off and put this one on. Or my variable, 0 to 30, which is a switch mode power supply. But they're a lot quieter. They have more capacitors in them for filtering. Or I can up the microfarads for more filtering. Can't go too much, though.
I never knew you had a radio shop there, Boo.
Didn't know what?
I didn't know you had a radio shop years ago.
Yeah, years ago. Yeah, I had 2. My first one was in Abbeville, and they asked me to move my business over there to Grosstedt, Tiger Truck Stop.
Cool.
Like 60 miles away. I did. Stayed there 10 years in business.
Well, interesting. Now, Arch here has a question or something. His statement was you can't change a waveform that is flat or clipped. You can clean it. Well, you could look at that, Gary, because I don't know what the hell he's talking about.
Without invert, yep. With some electronics, yeah, he's talking about clips. Just like in audio, you can't. It's great. Distortion sounds great in a guitar amplifier, but when it comes to powering devices, not so much.
Right.
And I did see a comment before about from, I'm going to pronounce her name wrong, Orteria. She says converting square waves has always been a huge challenge in electronics. That's why pure sine wave inverters are so expensive. Yes. If you're probably one of the biggest names in power inverters these days is Samlex, which is based over in British Columbia, Canada. And I worked with them many years ago to actually fix one of them. And I even have an entire video series on it. And I was flying blind. I was still kind of, getting my feet wet with that. But there's some very complex circuitry to make that happen. And it can even be said, Boo, that inverters are actually switch mode power supply amplifiers, because you're taking 12 volts DC and amplifying it to 110, 120 volts AC. Right. But it's 4 times the output. So it's got to come from somewhere. If you're going to power a 100 watt bulb at 120 volts, that's going to be about 10 amps on the 12 volt side. So 10 amps at 12 volts to give you an idea. If it's close, switch modes can be very efficient, like 90% converted to the load. Linear power supplies for that little 7 amp you got there, probably a big heavy transformer taking 120, probably stepping it down to like 24, maybe even 20 volts, and then that linear voltage regulator brings it down to 13.8, and the rest of that voltage that's higher incoming is going to bleed it to ground, and that's where you get all the heat.
Yeah, like energy, energy, heat.
They're great. A lot easier. I love my tube amps. In fact, I have very unique tube amplifiers below here that are actually switch mode power supply, but they have, a full valve section.
You're talking about that distortion early in guitar amps. The champs are known for that. The Fender champs, they are known for that. Oh man, sweet. You get all of that out of a 6 JC6, I think it is. I forget what was in them.
I got 6 CA7s in that one, and then 3 12AX7s and 2 AT7s, all valve.
You
See,
don't,
it's
you don't have,
old
okay.
Greek to me.
300 watt tube amplifiers are louder than 300 watt solid state amplifiers. That's all you need to know.
Oh yeah. And the sound's a lot better out of a glass valve anyway, or tube.
All right, Tom, I think you're trying to ask a question.
Just so for the Gary and James, the generators that you work on, how do they differ from the unit that's in your car? What parts are the same and what parts are different? So, well, we'll start with that.
Well, I don't do a lot of car work, but they're very similar in how they work. I think, both the generator, like a portable generator, and your car alternator, they have a field that can be changed in its intensity, right? So when a car is under load, it'll turn up the field, creating a stronger electromagnet. And same thing with an AVR on a generator. It turns up the power of the rotor, the electromagnet spinning. They both produce AC, but a lot of cars, probably built in the last 70 years, a lot of alternators, I should say, has the bridge rectifier built in. So it's automatically going to try to maintain that 14.4 volts DC out, and you can't really tap into the AC anymore because it's all built into one unit. The older cars, they actually have an external regulator, rectifier, and it's actually producing AC right on the alternator, and it's being rectified outside of the alternator. But they do produce AC just like a generator slash what's really an alternator in a portable mode. But they all produce AC, and it's just a matter of, size and, little differences in how they do what they do.
And then you mentioned electromagnets. So they aren't like a solid north and south pole magnet. They would be electrically generated magnets. For
cars and portable generators, yes. For inverter generators, usually permanent magnet.
Permanent magnet, yeah, just for reliability.
That's why they say if your generator's not making power, maybe you lost magnetism, and that's because a lot of like the alternators and generators, they don't have any permanent magnet in there. And I say that, but that's more the older generators.
Yep.
The newer ones, all with AVRs, they all have small permanent magnets on there, so it's really impossible to lose magnetism. It'll always have that permanent magnet.
A little bit of residual magnetism, yeah.
Yeah, and even in your car, I think when you start your car, right, it's actually going to send some of the 12 volts into the field in to your alternator to kickstart things. And even larger generators that might power your house, they have electric start. And when you hit the start button, it actually sends 12 volts from your start battery into the field to start that electromagnet up.
Yeah, you have to excite it, right?
Yeah, it's called the field boost circuit. It'll do exactly what James is saying, but it's also not only to excite the rotor, but it also turns on the AVR. Some of the AVRs won't turn on until it hits a certain voltage.
And talking about that residual magnetism and all that, that's of course why we say if you're using one of these home generators, unplug everything or shut everything off before you shut it off.
You're supposed to do that with anything.
Well, I'm just saying a lot of people don't.
Yeah. I mean, you can suck the magnetism out on the older generators for sure. And, the portable generators, a lot of them don't have that field boost. So if you suck out the magnetism, then it's gone until you put it back in there. But I think, a lot of the reasons why they say that too is just because if you have electronics plugged in and the generator is shutting down or say running out of gas, you're sending a lot of power surges to expensive things that you might break, and it's probably more a liability thing than any concern over the generator.
So you guys were saying that in modern generators, they are like a solid magnet, constant magnet. There's no electromagnetism in it. Why would they have ever? It almost seems more complicated to have wiring and circuitry to power an electromagnet rather than just have a solid magnet. I don't quite. It's almost like we've gone backwards.
No,
my head.
it's for reliability purposes. So a permanent magnet is only going to have so much output. It cannot vary the strength of its field. That field
No.
strength is fixed. So you're going to be limiting the amount of power that alternator can produce.
Right. So why is that advantageous? Why is that a modern thing?
Reliability. One less moving part. If you don't want something to break, don't design it with it.
That's so funny. I feel like we're going backwards here. Everyone wants to
Yeah.
put electronics and everything inside equipment, and now we're taking it back out again. That just seems a 180 flip for me.
Well, in some respects, yes, but I mean, on some of I'm seeing a lot of the portable generators get way more complex. Like portable generators, at least in the last 20 years, in the models that I've worked on anyway, pretty straightforward, very easy. AVR, bridge rectifier, capacitor, basic components that we normally see. Now, and when you get to the standby generators, the air cooled or liquid cooled standbys that power your house, we're talking entire microcontrollers that are running the engine management functions of the generator itself, as well as another microcontroller running the transfer switch. Now we're starting to see some of those more advanced engine management features in portables. Look at the latest Champion generators. You actually have carbon monoxide sensor.
The Furman. Remember the Furman?
Right. You have a carbon monoxide sensor now. You have a low oil sensor. You have a VFD, or a variable what is it called? The variable frequency module, where it's actually measuring the speed of the engine to make sure you're within a certain range. Otherwise, it's going to shut it down. You have a speed sensor that makes you have a voltage sensor that says, okay, well, if you're within this range, it's not going to shut the engine down. If you're over that voltage, it's going to shut the engine down. There are so many different boards and features that you're finding on these portable generators now under $1,000. It's very impressive, but that's making it a lot harder to work on some of these generators.
Repair, yeah.
Very difficult. The schematics are out there, and I cannot tell you how many times I've gotten a couple emails since that I posted something about a Furman generator that Ken actually has, that I'm going to probably dig into at some point. That how do you bypass the carbon monoxide? And Furman down in Arizona is like, don't do that. Don't tell them. Well, you provide the schematics. I mean, how am I supposed to go and troubleshoot it? Well, spend the $20 some odd dollars. They're not that expensive, but I mean, if you want to, if you want to go and play with your life with disabling the safety feature, yes, I'm not going to be held responsible.
Is there a reason for bypassing the carbon monoxide sensor?
Well,
just to get it running, because
the unit will run, and if it'll run without it, that means that's more likely your problem.
Possibly. I mean, it's from a diagnostic perspective. It's good to know how to bypass it to eliminate it.
Gary, didn't you say they had a lot of bad ones?
They had a lot of bad. The sniffers that are on that board were causing problems where it would literally shut down within like 2 minutes or less, or in 30 seconds. Now, when you see that happen on a less complex generator, James and I have many times bypassed the low oil sensor. It's either a pressure sensor or it's a level sensor. There's a difference. And if it keeps the engine running, well, then that's the problem, because some of them do wear out. They get stuck, they get corroded, and you have to replace them. The carbon monoxide sensor, I mean, as long as you're outside, if it's shutting down when it's outside, but then you disable this carbon monoxide detector and you're in the open air and it still shuts down, be a little suspect of that sensor just, nuisance false tripping it. But even there's other sensors that fail, that if it can't sense because we go back to that total harmonic distortion, that if you can't sense the speed of it's looking at the AC frequency, which is a direct connection to the engine speed. No, sorry. Engine speed is directly correlated to the hertz for a traditional generator. So if it's not in that speed range,
if your RPMs are too high, your hertz are going to be.
Say that one more time.
So if I have typical generators, like portable generators, like say sub 10,000 watts, have a 2-pole rotor. So you have a north and a south, right?
Yeah.
And then in order to get your 60 hertz, you need to run at 3,600 RPMs in order to get your 60 hertz. Now, when there's no load on the engine, it's 3,750 RPMs, which is about 62.5 hertz. Now, if you can't really go much beyond that, because most devices are going to be pretty forgiving up to that point. Anything over 63, 64, and then you're going to start, possibly getting problems there. Electric motors can
Okay.
run faster and stuff like that.
Right.
Conversely, too, anything less than 58 hertz can tend to be more of a problem too, because now you're actually drawing more current because you're not able to get the power to move into the load as efficiently. So it's a very narrow range that generators need to run in, and that's why they have these sensors that will shut the machine down so that until you can fix the problem. So yeah, but yes, so there's over here in the UK, you could 50 hertz, 3000 RPMs or roughly. Yep.
Yeah.
But that's the reason too, though. I mean, we've burnt out motors before because we didn't realize they were European 50 hertz motors, and we threw 60 hertz at them.
Yeah, well, you're running them much. Well, if you're taking a six, I got into an argument with someone on this, so I'm going to shut up now. Someone's like, "Oh, you could run a 60 hertz on 50 hertz." I'm like, there's
No.
no.
You can run it.
You
for
could
a
run
minute.
it, but it's
Oh,
going to
no.
run less efficiently and it's going to run hotter. It's
Yeah,
gonna
we
draw
melt
more
them.
power.
Yeah, because we had a machine come over from Europe, and they
Mhm.
told us they converted everything to 60 hertz. The tag still said 50 on them, and we didn't bother to check. We plugged it in. Within an hour, we melted all the motors.
Exactly.
Because you got to get the equation, the E equals IR has to equal somehow. And what's going to happen? Current. So,
So you were saying earlier, Gary, or was it James, that the generators that you guys all work on, they are the overwhelming majority are electromagnets. Is that right? Is that what you said?
Yes.
Yeah.
With the exception of the inverter generators, the smaller suitcase ones, because they typically,
With the exception of the inverter generators,
Yeah,
that was it.
for something that small, say sub 3000 watts, when you start to get to the larger inverter generators, I mean, I haven't come across one, but I would imagine that if I was to look at a schematic, you'd probably find an electro magnet or a typical rotor.
Right. And you guys said that, or was it James said that in a car it will be an electromagnet, but then on the other hand, you also said the electromagnet is older technology. Am I right?
Tom, if you wanted to really get messed up, I went after talking to you today. I went to the Delco Alternator website, and now they're making brushless alternators for cars. Read about the technology of that; it'll blow your mind.
So a car alternator's brushed typically.
Typically, yeah.
Oh, they are.
Yeah.
Oh, okay.
But they said now with the brushless acting like a rotor stator, okay, the way it's doing it, it's a lot more efficient, a lot less heat is generated. It's really cool. Just go to the AC Delco Alternator website. There's a website for it. It'll talk about the technology. It's pretty cool.
No, it would probably just go right over my head. Really,
No. It's actually in layman's terms. It really is. Not too bad.
Is it? Okay.
Yep. Oh, here we go. Arch, we use VFDs all the time because we kept smoking the what you call it, the silicon what is it, Gary?
Silicon controlled rectifier.
The SCRs. Yeah, we kept smoking SCRs, so we've gone to basically all VFDs. Plus, with the VFD, you get a soft start. You're going to ramp it up, and you're not frying anything.
Someone mentioned earlier about flashing a generator.
Yeah, when you lose residual magnetism, you could flash it with 12 volts or a little bit under and get it back.
Yep.
Right. So that's another disadvantage of having an electromagnet, that you have to flash it, because you wouldn't have to flash one.
Well, only if you lose it.
Only if you lose it.
Yeah,
Most
of course.
the time they have them in there.
Oh, okay.
Yeah, you have to watch, Arch. Yeah, you do. You have to, with starter capacitors, all that stuff. Yeah, you got to watch what it is. Yep, I agree. But VFDs are great, especially in a machine shop. You want variable speed on your Bridgeport or your lathe. The problem is you only get half the power. So you got to watch.
Kenny, on a ride-on mower, we were talking about ride-on mowers and their charging systems. Would they have brushes too, like a car? They would. The alternators would have.
No. It's a rotor and stator. It's an alternator.
Oh yeah, of course. It would have a.
Listen, man, listen.
Yeah, typically on all the Briggs and Strattons and pretty much any small engine out there, at least nowadays, they have a stationary stator, and then they have a spinning flywheel with the magnets on it. So
right, that was it. Yeah.
So the armature, the armature is stationary in this case, and then you get power out of your your stator there.
I tell you, Arch, I didn't realize how talented you were, my friend. I got to go back and look at some of your older videos.
Yeah, that's it. Yeah, that like a very simple method of generating power.
Yep.
Yeah.
So, Tom, what other questions do you have since this is your stream tonight?
I think I've asked most of them. I'm trying to just digest it all, really. It's hard. There's a lot to digest. And really, it doesn't need to be. For the things that I'll ever come across, it's going to be very simple. It's going to be a flywheel. It's going to be flywheel, magnet, and then what do we have down? A rectifier going to a regulator, going to a battery. But on occasions where, for example, you've got a vehicle, then obviously it is slightly different. But it's not something I'm going to come across a huge amount. The other
what
thing
about your outboard motor, Tom? Did you want to ask any questions about that, the charging system in that, or?
I think we covered it all, really, because that's very similar to ride-ons or anything else, isn't it? It is literally just
It's a stationary or stator, and then your flywheel on the outboard has the magnets, just like a lawnmower.
Yeah.
So that's what's charging your battery. Now those are a little bit more beefier on outboards because there's more of a demand on a boat than there is on a lawnmower, naturally.
Yeah.
Yeah, that makes sense. Yeah.
Like on my 15 horsepower John Deere, here's a really good picture of what the armature looks like, or the stator in this case. It's on the top. I took the flywheel off. You could see that's about a 20 or a 26 amp, because this my model had the external hydraulics, and you could have had all the motors for your snowblower attachment.
Is that the most powerful one though? Or no?
I think that is one of the most powerful. It's a Kohler CB15. It might be.
Yep. So where was your ignition core? Where was that sitting in relation to that?
Under the flywheel. What do you mean? That's the stator under the flywheel.
Well,
didn't look like there was any space for it.
There was because I didn't. You can't see it. It would have gone right here.
Okay, I got you.
So this is your stator right there. I didn't have it. I actually wound up, if you could see, I replaced the cylinder head a long time ago.
Oh, cool. Okay.
New piston.
So all of those
glider engines have those high amp alternators of charging systems, because you have a PTO clutch on there that's electric. If your battery goes down a certain voltage,
it'll shut down.
Your PTO for your belt, for your blades is going to shut down.
You know what really screws me up, Boo, is the Skag I worked on 2 or 3 years ago. No battery, but a capacitor and a rotor stator. That was fun troubleshooting that.
No battery, just a super capacitor.
Battery, just a storage capacitor.
Very high farad capacitor that acts as a battery.
That was fun trying to diagnose why the PTO wasn't working.
Yeah, we call that super capacitor. Yeah, no battery. Oh, the battery was out, or was it just dead?
No, there was no battery in the circuit. Skag, it's a Kawasaki system that runs with just a capacitor that gets charged from the stator and keeps enough in there while it's running to keep the PTO supplied with enough current.
Yep.
Okay. I'm not that familiar with
it's weird
with Kawasaki's.
But what happens is when they overload, they melt the rectifiers.
Yep.
Oh, okay.
Yeah.
They have the rectifiers in those. Like I said, I'm not familiar with Kawasaki's, like the Briggs do with the diodes.
Yep. But
I got 1,000 of those.
It's almost like the big square potted Briggs one that you see on the side of the Intex.
Oh, okay.
I was just going to get a picture of that.
With the yellow wires coming out.
Yeah.
Those diodes or something in there. I don't know. I've got some bridge rectifiers right here in front of me. I've got the regular diode rectifiers, the 3 amp, the 1 amps. Then the other ones are 5 amps. The big one, the bridges are 5 amps, I think.
Yep.
All I know is I bought a rectifier for it, and I hooked it up to a variac to prove it was going to do what it was going to do at 26 volt AC input, and it did. Now, someone was asking the question before. Who was it that said he had a variac that puts out DC? Well, that's impossible. I thought a variac was variable AC.
It is.
Well, me too. I mean, all the variacs that I know of.
Variable AC. I mean, when I think of a DC, I think of like a train transformer,
Yep, could very well be.
Yeah. Here's Adam again. What do we got here? Oh.
What's your Variac? You got a little red one with a knob on top?
You want to see my Variac? It's huge. Give me a second. I'll show you.
Oh, you got the old style ones? Okay.
Oh, no. I got the Tombstone.
Well, as long as the Variac.
Oh, okay.
Variac is a marketing name. You know, they're
Yeah. Oh, yeah.
You know, they're the newer Variacs or the cheap ones from China are brush type and they are not isolated, which is interesting. And they fail all the time. A true Variac, which is a variable transformer with that big knob on it, you know, they don't.
Here you go, guys. This thing weighs about 27 pounds.
That's a real one.
Oh yeah,
that's real. That's got isolated.
Totally isolated from earth to ground. Totally isolated from that.
It weighs about 20 pounds.
Yep.
Yeah. Okay. I know
why those are so expensive.
Yeah.
Guys,
this one was about $400.
Yep. That's
you hook that up to a tube type amplifier, say a Fender Champ, and just say something goes to ground, something hot in there goes to ground, and you touching it, it's just going to invert back, and from that hot to ground, and you're not going to get killed or shot.
The only thing I can say about using a big Variac like this, make sure you have appropriately sized connections and not teeny alligator clips on 16 gauge wire. Because when you turn it on, it goes. It's like a mini arc welder. Yeah.
Yeah, I've got those big heavy duty alligator clips.
Here's my that's my guitar amplifier with my 6 CA7s. I was doing a bias on it.
Okay. You don't have a 12AX in there driving?
There's two 12AXs. There's two 12AXs for the preamp and then one AT7 for the phase inverter.
Oh, okay. Yeah, I got a bunch of them 12AX7s, a bunch of those.
Yep, very common. And then last but not least, I have the more. Oh, this will be my last one, then, guys. Then I got a jet.
Yeah, it's getting late.
Yeah.
Yeah, I got a jet myself. So.
Here we go. Can't really tell, but it's hard to see. But that's my matched octet. I was biasing my other amplifier that's sitting behind me. So,
okay.
Fun. Guys, it's been fun. Really appreciate the time. Tom, I hope we were able to answer some of your questions there.
Thank you, Gary. I appreciate it a lot. Yes, mate.
Gary,
I'm
Jim,
going to have to rewatch this a couple times.
I appreciate everybody coming up. Oh, we did lose James. Oh, wait. Where's James? James here? Hold on.
Yeah, he popped off.
Oh, hold on. Hey, there he is.
How you doing?
We lost him.
Hey, talking about Eddie Van Halen real quick. I watched a video. Who's our guy that we watch, Gary? The guy that does all the music, analyzes the music. The gray-haired guy.
Rick Beato?
Rich Beato. He did the one where I watched an old video of his the other day where Eddie Van Halen was varying the voltage going into the amplifier to get
the brown note.
Exactly. I love that video. That was a good video.
It was the basically he was using a Marshall head, and it was wired for 240, and he had plugged it into 110, not realizing that it was for 240. It took forever to warm up the heaters inside the valves. But then but
there's that magical number, 78 volts, that gives you the Van Halen sound, supposedly.
Yeah, somewhere around there. But what's basically happening is you have to rebias the tubes or the valves in order to get that kind of sound. You basically make the tubes work harder in order to get that sound. But the valves don't last very long. Valves, tubes, one and the same.
Yeah.
All fun stuff, guys. Believe me, I usually run mine a little bit cold just because there's only 3 major factories in the entire world
that make
valves right now. Yeah. And the most expensive is over. They have China, they have Slovakia, and then they have Russia. Now I love Russian tubes, but EHX and any Tungsol, any of those tubes, you're spending $65 to $78 a power valve.
Wow,
that's how expensive. So imagine a matched octet of 8 valves or a sextet of 6 tubes. I got those for about $38 to $40 a tube before the market went crazy and then all the sanctions and crap went on. So I wouldn't even think of buying them right now. It's a king's ransom.
Well, if you're a YouTube channel and you have 500,000 subscribers and you come up with this amp design, a tube amp design, okay, and you put out the parts list and you show it on your channel, and you got that many subscribers. There's a lot of these online order companies. DigiKey is one of the biggest companies in the world for parts.
Yep.
And then all your tube places, you know, man, they get sold out in a week from when you put that video up. They get sold out in a week, just like Mr. Carlson's lab. He comes up with this new technique, like at Super Pro, you know, or something with an iPro, you know, iTube, you know. Can't find iTubes hardly no more because of that man right there.
Yeah. Well, that's that's one of my major hobbies. I don't post a lot of those videos on the channel because I still like to learn more about the valve tube designs. But you know, me, I have some of the probably two of the most rarest tube amplifiers ever made by PV Electronics. So you know, you have a switch mode power supply that's Class D. It's basically, you're eliminating a 50-pound transformer because normally tube amplifiers have two. One big one for the transformer to step it up to the high voltage, and then another one to match for your speaker
audio.
For the audio, right? Because you have a high impedance to a low impedance. That's all that does. But who wants to bring around a Ampeg SVT that weighs 95 pounds? Nobody. This thing weighs 37 pounds and 300 watts of all tube amplifier. You just don't see that anymore. But because of the economy of valves these days, you don't see many companies making that. They're making a lot smaller wattage. You know, say 20 watts, for example, that's more economical, but you'll never see an amplifier that big made anymore. Just not going to happen.
That's a lot of power.
Yeah, I love it.
I love when I turn on my my Seaberg here, right? And I got to wait about a half hour for everything to warm up.
Yep, and then your pants will be flapping.
That monaural sound, oh my God.
They call it single-ended. Yep.
Oh, it's deafening with one speaker. It's amazing, the sound. Hey, 1951.
Yeah.
That was the technology. Yeah.
Cool. All right, guys, be well. Thank you,
Gary,
guys.
thank you so much. Appreciate it. I'm going to hit it too. James, again, thank you, my friend. Hope you feel better.
All right.
Feel better,
Thank
guys.
you.
Thank you,
Yeah.
James.
And Tom,
Thank you,
it was for you, buddy. Hope you enjoyed it.
Yeah,
And Boo, always a pleasure. Why don't you take us out, Boo?
All right, everybody. It's good being north of the grass. Stay safe. Stay north of the grass, please. And as always, love, peace, and crackling grease.
There you go.
Catch y'all later.
All right, guys. Take care. Have a good night,
Thanks,
everybody.
guys.
Take care, everybody.
Have a good night.
We'll talk to you soon. Take
Yep.
care.
Bye-bye.
Bye-bye.